So in this video, I want to talk about two very popular Python libraries for looking at data, um, Pandas and Numpy. Both are great libraries for working with data sets and manipulating them, but they have different uses, which if you never used them before, you might not be aware of. So first I'll start with Numpy. Numpy is meant to be used more with numbers. It's great at making calculations and is very efficient, especially with smaller data sets. I mean, it can work well with large data sets, but once you get over like 500,000 rows, Pandas is thought to be more efficient with those larger data sets. NumPy is array based. And as I said, it's great at making calculations. That's why it's used heavily in neural networks and the calculations that occur within them, calculating the dot product and things like that. Where Pandas works better with tables that have features and labels. I'll give you an example in a moment. It does work well with numbers, but not as efficient as NumPy. Its main feature is not the array; it's called a data frame, and you also have series in there. And like I said, it works. It starts to shine a little bit when you have these large data sets. Anyway, a real quick example of just some basic things with each of them. There's this data set that I got from Kaggle.com that this is a small subset of that data set that looks at different foods and their macronutrients, protein, fat, carbs, and such. And you can bring that in a future tutorial. I'll go into this in more detail about how you can bring in CSV files, but you can import this in and it will come in as this array, the NumPy array, which is the main component of NumPy. And you do have access to all the rows like you would in a standard Python list or Java array. It looks kind of like that. And you can use this as a multi-dimensional array, of course, something like that. But anyway, this would print out the first row. But when we look at this and you would say you wanted to access all the values in the protein column, you don't have an easy way of doing that in NumPy. You could, of course, use a nested for loop to get those values and save them. Otherwise, you need to do this transpose, which basically flips the data set 90 degrees to the right, and now protein becomes a row. I'm sorry, to the left, and then protein becomes a row that you can access as such. Anyway, I just point that out. That's a quick little thing, nuance of how NumPy is not as fine-tuned to work with data sets that have these labels and such. It's more just like pure numbers. And by the way, when we import this in, you do have to declare a data type. And so this has these labels. So you want to come in as a string. Then later on, you could convert parts of it to floats or ints. Anyway, in comparison, let me show you Pandas here. You import the same data set, and you notice that by default, it expects there to be headers, and that's why when you try to get the first spot 0 in the protein column, you actually are it knows right away that it's going down one from the label, and you actually have access to that column right away by just using the name of the column, which is a nice feature in Pandas. It also adds these indices by default, which again, nice feature in Pandas for that. But you don't have the fancy functions for math calculations that you do in, say, NumPy. Anyway, that's really it. The other thing I was going to point out is you can, though, use Pandas, and then if you need to do some of those calculations, you can convert the whole database to a NumPy array using this function here. So as I said, in future tutorials, I'm going to go into more details about how to use each of these libraries. I'm going to show you how to use it with matplotlib and do some really cool graphing. So I hope this is helpful as a first exposure to Pandas and Numpy. Thank you.